Hello. All right, so let me just share the screen, please. All right. Okay, before we start our lecture for today, right, just have a look at our course plan. Okay, last week we look at OSPF, right? So we look at the part two actually, yeah, the configuration for single area OSPF version 2, right? So today, I want to cover the part one, which is the theory part of OSPF version 2. It's not many slides, right? Only about 30 plus. And after a brief break, then we'll continue with our um, network security concept, right? Now, network security concept talks about all the possible um, network threats and also threat actors on the network security. And it continues with security with the access control list. Yeah, the ACL concept for the week after is actually a continuation of securing our network, right? So they are sort of related in a way, right? So here we identify um, network security, and then one of the ways we can secure network is by using access control lists, right? Right. So before that, let's briefly go back to OSPF. Let's talk about the concepts, yeah, before we can proceed. So as usual, I will record. Right. So there might be some overlapping from the configuration part of the OSPF, but that's okay. Yeah, we go quite fast on this one. Let me just record first. Right. So chapter 2, single area OSPF version 2 concepts. Right, so here we just look at the theory part of OSPF. We know that OSPF is a way for our routers to share routing tables, especially for DR and BDR. Okay, if it's selected, any router selected as DR will basically share more detailed information, including routing table information. But those who are not, that means other than DR, BBDR, will share only link state, yeah, link state. Right, so we start with describing basic OSPF features and its characteristics, and then we move on to packet types that is used in single area OSPF, and a brief explanation of how single area OSPF operates. Okay, so let's take a step back and look at it in an overview, okay, of routing protocols. Routing, as we know, is a forwarding decision made by the router based on routing table. The thing is, a router only knows about directly connected networks. But in order to perform its routing, right, it needs to have the entry, matching entry in its routing table, right? So if it only knows the directly connected networks, I think its information is incomplete. Thereby, it also knows at least one hop away the information about the remote networks, and this can only be shared by other routers, okay, or neighbor routers to that router. But the thing is, where do we stop, right? If we have routers sharing information, where do we stop? We can't have all the routers on the largest internet network, which is the internet, all sharing information. So that means we have to do it in area base. It means in the organization, all those routers that belong to your organization you have access to, you can manage and monitor. Those are considered as an area lah. You are free to segregate your areas. Okay, but if you like medium size, probably you have a single area lah, right? Unless you are a larger organization, then you have multiple areas, right? But this still under your control. And the boundary of this area is what sets your routers versus other organization routers, right? So whether your organization will share information with other organization, that's depending on the what lah kan, the communication between your organization and the other organization. But typically, they do not share lah, unless you specify that they won't share, right? So when you look at the classifying of routing protocols, right? We have dynamic routing protocols. Dynamic here means the router once set up, they can work independently of the network administrators. I mean, network administrators do not, after setting up the routers, do not need to do much in terms of updating, okay, updating the routing information. In fact, it should be autonomous. So the dynamic, you can see that, for example, under OSPF, if a router goes down, if that router happens to be one of the DR or BDR, then an election can happen to elect uh, another router, right? Okay, so under dynamic routing protocols, we have interior gateway protocols or IGPs and exterior gateway protocols. Interior gateway protocols make use of distant vector routing protocols and ring state routing protocols. Okay, so under distant vector routing protocols, you can see the older ones, RIP version 1, and the new version, RIP version 2. And IGRP is actually Cisco's private or own routing protocols. Now it's now new version is called EIGRP or Enhanced IGRP, right? Inside routing protocols, we have two, OSPF and ISIS. ISPF basically a standard, okay, protocol. That means it's open standard. And then we have the exterior, which is for the larger area. We have the path vector routing protocols, and it's called BGP, right? So this places our OSPF in the context of other protocols, as you can see here, right? So that means OSPF is for your own area, interior gateway protocols. And then if you want to go beyond, then you have to consider other protocols like BGP, right? So you can see here multiple areas or segment of the internet network, right? Where um, combination of the protocols we mentioned earlier on, the classification, is being used by organization and they are interoperable. And when you see exterior means it's on the larger internet network, okay, beyond your own area, you will use BGP as the protocol to communicate. So some organization might choose to use routers that implements RIP, some probably as OSPF, some EIGRP, right? And some ISIS. Now it depends on that organization which one they prefer to use, right? As I mentioned before, SPF is the standard, EIGRP is Cisco proprietary, RIP is an older version, also open standard, but older version, right? Right. So we focus on OSPF. So OSPF is not the only one, right? You can see that from the classification just now and also in this diagram, right? But we focus on OSPF, right? So under the classification, we know that OSPF is a link state routing protocol, right? So it's an alternative protocol to RIP, which is routing information protocol. Now, the thing is, usually when we have an offshoot like this, where OSPF is developed separately from RIP, is usually to provide extra functionalities. So you can see here, OSPF has significant advantages over RIP. Okay, so if you, for example, why should I use OSPF compared to RIP lah, right? So OSPF offers faster convergence. Convergence, a lot of times we talk about convergence is that if it's dynamic from a default state and it goes into operating state, okay, we call that convergence. Means include a process like the election. Okay, prior to election, the routers do not know which are the DR, BGR, right? BDR, sorry, in OSPF, right? So the process of the election until the DR and BDR is elected, that is considered as one example of convergence, right? Right, so it's offer faster convergence and scales to much larger network implementation. So if you're thinking about you're having a large network, right? So OSPF might be more optimal to use, yeah, compared to RIP, right? So OSPF, remember that we can set the OSPF process, but we also can set that all the routers within the single area will have the same OSPF ID. So OSPF is a link state routing protocol that uses the concept of areas. So a network administrator, for example, can divide the routing domain. So this area where all the devices are under your control. So you can, if you want, divide the routing domain into different areas, right? The thing is you have to be able to manage, right? To manage, and if the whether you want to divide into many routing domain or single domain, depending on how large is your network and how easy it is to monitor and maintain, right? So what do we mean by link state? Link basically is an interface, okay? The interface on your router, right? So a network segment connects two routers. So let's say a router connect to another router. So the link between the two routers is actually one segment, and it could be the segment could be just a link between two routers or is part of a network, right? I mean network with hosts, right? So the thing is whether the router is up or down or a specific interface is up or down determines whether that segment is down or not. So this is part of the information that we consider in the link state, right? The link state can be also the not only the status of that link or interface, whether it's up, down, shut down. It also includes all the details like IP address that interface is given, right? So you can see here additional information is also included, like network prefix length. That means that is the network lah, right? The network slash something that's prefix, and that indicates to us what is that network class belong to, right? And the cost for that link. We also have looked in the configuration section when we want to find the best path. That means the best path will be the path that is entered into the routing table. Maybe you have multiple paths, right? Just like when you want to go for campus, you can take multiple path, different road, but based on the traffic condition, right? And maybe you use an app like Waze, yeah, you can decide to take a road that is maybe less traffic, okay? Or if another road is blocked, then you don't want to, you can't go through that, then you can choose another one. So basically the path management by the router, okay, is very similar, right? So how do you remove a path? Means you just don't have an entry inside the router. So a path that doesn't have an entry inside the router will not be selected. Okay, the path that has an entry in the router will be part of the selection, become part of the decision by the router, right? So how does the router select? Okay, based on the algorithm being used. Okay, so OSPF is using shortest path, right? Algorithm. So the selected path, okay, will be the for OSPF will be the one having the least amount of cost. So it will be the path that is entered in the routing table. Therefore, when the router needs to make routing decision, it simply just go through the routing table and select the path that match. But in order, but we have a separate algorithm, whether if you have multiple paths, whether that path is entered into the routing table. If a path is not in the routing table, then it's not part of the decision making of the router, right? So all this link state information is available for the router only for the directly connected network. How about the remote network? So that's why we need to have this protocol to exchange this this information as stated here, so that the router also have information about remote networks. So the router that is connected directly to those remote network to that particular router, we'll have to share it. Okay, we'll have to share it. All right, so we're going to focus on single area OSPF implementation and configuration. Configuration wise, we've already covered it earlier, right? All right. So our all routing protocols, because they are routing protocols, that they share a common functionality or similar components, right? So they for any routing protocols, they need to share information. Okay, so that means the protocol governs messages that's understood by all the routers that adhere to the same protocol. So they will understand the messages they pass among each other, right? So these messages are used to populate whatever data storage or data structures that in example will be routing table, right? That is going to be used in the routing decision, right? And also complemented by routing algorithm. What is this routing algorithm? To help select, if you have multiple routes, to help select in terms of that protocol, which is the winning path, which is the winning route, so that it can be entered into the data structure or routing table, right? So routers running OSPF will exchange messages to convey this routing information, and they have 5 types of packets depending on what is being shared. So we know that the neighbor routers send each other hello packet. And we also already know that when we configure them, we can configure the hello, how long the hello message is, period for it to be sent, right? So every period, then it will be sent. And we also know that the timer, the time elapsed when the hello mess packet is not detected, that the router will consider that part of the network is down, right? Then we have the database description packet, link state request, link state update, link state acknowledgement, right? So routers also use this packet as a way to know about the topology of the network. So it is used to discover neighboring routers. So if a router know, oh, I have how many neighbor routers, then it will know there are so many paths, right? So many paths, right? And depending on the shared information, the router should know which path leads to where, right? Right. So OSPF message are used to create and maintain 3 OSPF databases. Adjacency means which router is next to me. Okay, I'm connected to what is the router connected to me directly. So adjacency database, and the data is stored in the neighbor table, right? So inside the neighbor table, you should find a list of all neighboring routers. Okay, so this table is unique for each router because its perspective is based on that router itself, right? So the command to view that is show IP OSPF neighbor. Then we have the link state database, LSDB, and the table is a topology table. Inside this um, data storage, you can find a list of all other routes, so routers in the network. Okay, in addition to the neighbor. Neighbor is the one directly connected to you, right? The router, the next hop router lah, basically. But in order to have an idea of the larger network, then we have this topology table, right? So the database represents the network link state database. All routers within the area have identical database. So that means the topology will be seen as the same from any of routers participating. So you have a look at this table by typing this command: show IP Ospf database. And then we have the forwarding database, and this is the routing table itself, where it contains routing entry. So the list of routes inside this routing table is generated when an algorithm is run on the link state database. So you have the topology. Basically, we see the topology as a topology diagram, right? But of course, in the router is software, so it looks at it as a like a graph network, data structure. It's a data structure basically, right? So I'm pretty sure Noel and Kelvin, Farah not yet, Noel and Kelvin, you're doing data structure algorithm, right? Correct me if I'm wrong.
Oh yeah.
Yeah. So do you have graph network inside or graph data structure inside your as a one of the topic?
So far haven't.
But do you see as part of the syllabus?
Uh, Maybe I haven't see the
Maybe, yeah.
note.
Okay, so if usually graph data structure and graph traversing algorithm is one of the a very important data structure in computer science. Others like binary tree, you have like linked lists, you have all these, right? Stacks, queues. Graph is one of them, and graph is important because a lot of the system of networks that we have, whether it's networking or for social media network, they all can be represented as a graph diagram or graph data structure. So of course, network is form of graph, right? So in fact, the best storage you can do is a graph storage for the topology. The thing is, including the data structure is also the traversal algorithm. So if you have a graph data structure, then you have a graph traversal algorithm. Traversal simply means how do I go from this node to that node, right? So you can basically imagine the algorithm, right? That means when you go to topology, you basically got a graph, right? So when you have an algorithm, when you do the traversal through the graph to any node on the graph, you can, based on your costing, based on the way you metrics for costing, then which path of the graph you traverse has the least amount of cost in the terms of OSPF, looking at the least amount of cost, which means you can decide, okay, as the algorithm can come up with, oh, this path, when I do the traversal through this path is the least amount. So that is the chosen path. Okay, so that means that you identify, if I want to go through this path, which of my interface should I begin forwarding? So that becomes the entry in the routing table. So you can see list of routes generated when an algorithm is run on the link state database. This algorithm is a traversal algorithm, and the traversal also calculates the cost of the path. The selected one, the winning path, will then be entered as part of the routing table entry. Okay, so in our router, if you want to see the content of routing table, you type show IP route. Right? Is that okay so far?
Oh,
Yeah.
Okay.
I think you start to notice, although some of these ideas and concepts, they come from they are basically different areas of computer science, but ultimately they are related. Some knowledge we get from other course can be applied in another course. For example, just now, like the data structure and algorithm, content applicable because of the algorithm. It's applicable in networking, right? Right. So components of Ospf. So router builds topology table using result calculation based on Dijkstra. Dijkstra is for me is a genius like in computer science. Fortunately, he already passed away. He has many algorithms, not not only the shortest path first algorithm, but a lot of very important. Okay, not replaced yet, improve yes, but a very important algorithm in computer science. So one of his algorithm is this shortest path first algorithm. So Dijkstra is a computer scientist. He's Dutch, right? Unfortunately, he already passed away, but his work lives on in most of our technology, right? So SPF algorithm is based on cumulative costs to reach a destination. Again, this is necessary because not all path is going to be entered into the routing table. So which one should you select? So since we are using shortest path first algorithm, this one calculates cumulative cost. As long as we know we allocate the cost is based on what, then we can get a winner, right? The SPF algorithm creates a SPF3, right? Again, talk about the three. Okay, so that means the graph is a three graph. It's a three is a form of graph. So it's traversal, right? So traversal means you from one node to one node. Let's say from here to the end here to the leaf. So you traverse calculating the cost, traverse calculating the cost, right? Now it's not literally traveling through the path. Okay, you traverse through the nodes as part of the data structure. Data structure, this can represent the data structure. And the algorithm for you to visit the node here, 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 here is the algorithm, right? So here the algorithm is the shortest path to the node and at the same time calculating the cumulative costs. Each segment has a cost. So as you traverse, you add on, you accumulate the costs. At the end, when you reach destination, what is the cost? Then if you have multiple path, you compare the path based on the cost. So the shortest path and the least amount of cost will be the best routes. Okay, and then that will be selected to enter into routing table. Okay, right?
Okay.
All right. Okay, so let's look at link state operation. To maintain routing information, OSPF routers complete a generic link state routing process to reach a state of convergence. So the following are the link state routing steps are completed by router. First, establish neighbor adjacency first. That means find out which is um, your neighbor routers. Okay, network adjacency means neighbor means your router connected to you. Then after you found out, then you already have a list of your neighbors, and then exchange link state advertisements. Okay, exchange means two-way. You share yours, and the other router share to you as well, right? Once you get the information, that means you know further than just your directly connected network. You know further beyond the one hop because it's shared by your adjacent neighbor. So you start to build the link state diagram. Okay, and then after that you execute because you are using the extra SPF right algorithm. Then you execute SPF. Then it should give you the best route. Once you get the best route, then you're ready to populate your routing table. So these steps, step by step, is need to complete, right? So from 1 to 5 is the time to converge. Once you reach 5 and then you have a routing table, then that means as a router you have convergence, right? Right. So this is as an example a diagram, a topological diagram that shows, yeah, and you can see the cost is provided, right? So router 1, okay, network 10 to 10.1.0.0.16, cost is 2. This is basically a virtual interface. Look back, and then router 1 to 2, okay, the network address is that, cost is 20. Here is cost is 5, here cost 20, right? Then let's move on to, yeah, yeah. Use hello packets to establish neighbor adjacency, right? If you're R1, you're adjacent to R2, 3, and 4. Use LSA to flood the area with cost instead of link. That means you're now sharing information, right? And then 3, you build your topology table, right? Okay. Then runs SPF, accumulating the cost for each path, right? And then you have this. So you can see which one should you select. So you should select the shortest path with the least amount of costs, which is this one, right? You can see here R1 to R3 cost 7, lowest cost among all entries. Okay. Each router will independently, because they already shared their information, they already build their own topology, they already run their own SPF algorithm. Then they have to build the routing table. Okay. Right. So each of the routers contain of the link state database with costs, right? And they will then um, come up with their own routing table later. Okay. Again, example. So you can see. Right. Next, single area, multi-area OSPF. To make this OSPF more efficient and scalable, OSPF supports hierarchical routing using areas. So that means more efficient and scalable means this. If you have the area is too large and only single area, then your all this operation that you're doing earlier on, okay, will be slowed down because there's so many information. The path becomes longer. Then your traversal become longer. Your calculation become longer. Means it's not very efficient, right? So if you have a small network, your single area is enough. But if you have large network, you divide into multi-area. So the thing is, each area means the routers within those areas will only interested within their own area. So their all the processing will be shorter, more efficient, right? Okay. An OSPF area is a group of routers that share the same link state information in their LSDBs. OSPF can be implemented in one of two ways: single area or multi-area. Single area, all routers are in one area. Best practice is to use area 1. Why? Because if you start with area 0, if you happen to scale up later, you want to go to multi-area, then you already have area 0, so you can just create area 1, 2, 3, 4, something like that in sequence you create. Rather than if you start with area 5, then what about 1, 2, 3, 4? Or should you go 6, 7, 8? So best is to use area 0 as your single area, right? So for multi-area, as the name indicates, is implemented using multiple areas in hierarchical fashion. So all areas must connect to the original backbone area, the area 0. That means it expands outwards. Okay. Routers interconnecting the area as referred to as area border routers. That means you are at the border between one area to another area. Okay, so our focus is on single area. So we can see that the multi-area, how is it? So this R1, R2 will be the border area. Okay, right. So we begin with area 0, right? Let's say we begin with area 0, single area. Then we expand outwards, and then become the other areas become area 1 or and so forth, right? So our backbone will be area 0, right? So we do this way is that your routing table becomes smaller because you're all in the area, you limit the number of routers, thereby your routing table, because it's only based on the exchange information between smaller number of routers, then your routing table is smaller. Or else, if not, you would imagine each router, the power, the components, the hardware components have to be like a server in order to be able to cater for doing the exact same thing, but like for a larger number of routers and routes, right? So small, we do OSPF multi-area, and you do it area by area. Then you can limit per area how many routers. Then because the exchange information is smaller, then your routing table tend to be smaller, right? Also, network addresses can be summarized between areas, right? So this is one of the command that you can do in routers. That is route summarization, right? It's basically when several areas begins with a certain network network address. Okay, so it doesn't matter uh, for the octets, but maybe let's say consider like you have the two network octets, say the same number, but then only the third octet network address is different. But you can summarize that, oh, this area all, you know, all the two octets the same, so we summarize it by doing by considering only the first two octet. For example, this is summarization of network address, right? Reduce link state update overhead means less information that you share means your bandwidth basically, yeah, right? Your bandwidth that you share the information can no need to be too congested lah, right? Okay, I mentioned this one already. The router doesn't have to be like a server, like a server kind of power or components, high spec, because we have smaller routing tables, smaller number of routers in the area, smaller number of information to be shared, then the router don't have to process so much. If your tree is now you create is very complex because too many information, then processing, traversal algorithm to process is longer and more involved, right? More complex. But if you have a smaller number, then it's faster. So minimize processing. That and all this need RAM to work on. So you also can reduce your memory requirement. That means your RAM doesn't have to be very big, right? Okay, so and also reduce frequency of SPF shortest path calculation, multi-area OSPF, localize the impact of topology change within an area. For instance, it minimizes routing update impact because LSA flooding stops at the boundary area. Because we consider this different area different topology already, which means if anything changed within one area, it is not propagated to other areas calculation because they are only focused on their own within their own border. So if let's say something happened here to change the topology, one of the link go down or whatever, then only the routers in this area need to have a topological change. Area 0 and 1 does not need to recalculate. All right? So that's what I mean by localize the impact. All right? All right, excuse me for a couple of minutes. I'll resume after a couple of minutes. Sorry. All right, sorry about that interruption. Let's continue. All right, so okay, so the area limitation, the boundary means it bounds the change in topology for routers belonging to an area only. Okay, if you don't have this hierarchical method of segregating the areas, then any slight change in maybe one router needs to propagate the topological change, because then the tree has to be rebuilt, then the path have to change, right? So everything has to change. So all routers, okay, will have to change. But in this manner, hierarchical, the boundary for each area will stop that. Okay? So it only affects those routers within a specific area, right?
So
Yes.
the area zero function as a middleman between all
No, it's, yeah, not middleman, not middleman. You're not. We don't think of area zero as connecting. We can. Yes, it connects area one and area 51, but you think about it this way: before area one and area 51 basically exists, let's say area zero was there. Okay, so as a network administrator, you should think that okay, now I have this network, right? So my routers are small number enough that I can say that okay, all my routers is a single area. Now, as a network administrator, it is best practice if I call my area zero. Okay, there are no other areas. Let's say so area zero. So that's my backbone. Okay. Now let's say I scale up. My organization grows. I need more networks, I open branches and all this, whatever lah, right? So now I expand, right? So my area zero is still my backbone, but now I'm now moving into multi-area OSPF. Simply means I have to create other for my other new routers or other segment, because maybe it's also grow here, it also grow here. So now I can divide or segment my entire network into other areas as well. So yes, in this that example, area zero does form to connect area one and 51. But I will also think of it this way, that area zero was there initially, and then as I expand, right, I create other areas like area one, area 51. Let's say area one, area zero is my original um, main main head office. Then I open branch area one. So then, okay, so I create another area one for my other branch. Then I open another branch, then area 51 is my other branch, for example. Okay, this is when we start with one single area. If we are already with two areas, I can also, if it's that network is large enough to have two areas, then in the first place I will have or already have multi area lah. But one of that, or one of it will be zero, one of it will be any number lah, one or whatever, right? And I identify my area zero as the backbone of my network. Okay, so that means normally in organization, it will be my main head office, for example, and that will be my area zero. Yeah.
oh,
Okay. Noel?
okay.
Okay. All right. Okay. So OSPF version 3, latest version compared to OSPF version 2. Right. So, but OSPF version 3 is I think is the next version because of capability to exchange IP version 6 prefixes, right? So it supports IP version 6, right? So here it says address family feature includes support for both IP version 4 and IP version 6. I think IP version 6 is a new addition. Okay, so further detail about address families is beyond the scope of this curriculum, right? So OSPF version 3, the new version, has the same functionality as version 2, but it uses IPv6 as network layer transport. That means it's basically looking to the future where we are going to fully utilize IPv6, right? Okay. So, but it's still the same. It's still a lot of functionalities is the same. It's just that it's now provided more support on IPv6 and still use the SPF algorithm. Okay, so to determine best path, right? So when we look at SPF version 3, we add in IPv6. It here it says separate processes mean it runs concurrently. Okay, it runs concurrently. So if you have IPv4, IPv4 is totally separate from IPv6. They are both running at the same time. They are separated. Okay, so you can see that the operations are basically the same as in IPv4 routing, but run independently. Okay. Okay, let's look at Ospf packets. The packets we already identify as hello packets, DBD, LSR, LSU, and link state acknowledgement. Right? When you receive hello, you want to acknowledge. Right, so let's see. So hello is used to discover neighbors and build adjacency. Remember, this is step one, right? Step one, to build a topology, you need to know your neighbor routers, right? DBD checks for database synchronization between routers. LSR requests specific link state records from router to router. Update means after you've been requested, you send the update lah, right? And link state acknowledge, if you receive any of this, in order to basically inform the other router that sends any of the other packets 1 to 4, then this acknowledgement need to be sent. Right, let's look at link state updates. Right, so LSUs are used to forward the OSPF routing updates. And LSU packet, that means every time you converge, you will share that converge table with other routers lah, right? There are different 11 different types of OSPF LSAs, right? For version 3, it renamed several of these LSAs, contain 2 additional LSAs, right? LSU and LSA are often used interchangeably, but correct hierarchy is LSU packets contain LSA messages, all right? So under 4, LSU sends the requested link set records. It contains this. So LSU contain this. So whenever it sends, what is inside will be this router LSS, etc., etc. Now, I don't think you have to memorize this in for your exam. They're going to ask every very, very detailed here. Most probably what is asked in the exam is the scenario and very similar to the computer network type of questions, rather than asking you to memorize these things. Just for your information, yeah. Hello packet, right? Send hello packet every periodic time, right? So this is OSPF type 1 packet. So it's used to discover the OSPF neighbors. Once it's discovered, it can then establish neighbor adjacencies, right? So also advertise what are the parameters the 2 routers must agree to become neighbors. There are the hello interval. Remember, you can basically set. Now, also remember during configuration earlier on, these 2 interval, hello interval and that interval. If you want the 2 routers to become adjacent, both setting of hello interval and that interval for the 2 routers that is adjacent to each other must be exactly the same. If you set 5 for router 1, then router 2, the neighbor, has to be set 5 also for hello interval. If they don't agree, then they cannot form adjacencies, right? Okay. Hello packet is used also to elect designated router and backup on multi-access networks. Okay. Remember we talked about election of the designated router, and then the second one becomes the BDR. Yeah. So it's using hello packet to do that. Okay. So a point-to-point link remember that for single area, we also have set of multi-access. We have point-to-point because there are no other routers. It's only the first router and the second router, and they're connected together, right? So there's no need to have DR, BBDR. Okay, they can just exchange the full set together, right? Why we have DR, BDR? For multi-access means you have more than two routers. Then you to reduce bandwidth, right? You don't want every other router. We prevent the full mesh connectivity. We don't want every router connect to every router and sending all this information out. Okay, instead we have the DR, the signal router, is the one that sending full information to all the routers. Okay, the other routers just send link state info only, minimal version to each other, just enough to maintain adjacency. But that means they all will share the same routing table info, but the DR is the one that is going to share it. So they all will subscribe to the multicast, right? So multicast means the one to many. So the one is the DR, the many is the other routers, right? So that's why we use multicast for sharing, right? This reduces the bandwidth requirement. Okay. Right. So let's look at Ospf operation. Under this topic, we have oh, hang on. This is a video, right? So yeah, under this section, we have this to check down state, init state, two-way state, start state, exchange state, loading, and full state, right? So let's look at the need for DR. Remember, we say we don't want this, right? We don't want the flooding to. This is looking at this. This is what I mean by fully mesh network, where every node is connected to every other node. You can see that every other node, and it's very expensive in terms of um, I mean, this is the idealized version, right? Every other node connected to every other node. If they are all sharing equally, then you can see share, 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 share. That means your network will be very congested because of the sharing, right? See, excessive number of LSS exchange between routers on the same network, right? Okay, so we don't want it to flood, right? So in a multi-access network where the potential to have this kind of connectivity is there, then we elect a DR because we only want the DR to share, right? So we have DR, BDR, and the other routers is DR others. Only potential DR, just in case the main DR go down. And then BDR will be elected as DR, and one of the DR other will become BDR. Okay, so DR is only used for dissemination of LSAs, right? Okay, so any question?
No.
No, straightforward,
No.
because we already look at how we configure all this earlier on. This is just to provide you the background theoretical information about it. So just to give uh, more understanding on the terminology that we used previously. All right, so that's the end of this section. Right, so I'm gonna stop my recording first because the next is the network security is a different topic altogether. So what's the next topic? The next topic we're going to look at is this network security concept, right? So this is a lot more about terminologies and description about the different types of network security issues and the threat actors. Okay, right. So let's start with it. And start recording this one as well. Okay, so what can we cover inside this chapter? I think this one is quite interesting chapter. We're gonna look at what is the current state of cybersecurity, right? We're just looking at it from you know um, overview lah, from what I see, right? Overview of cybersecurity of security lah, network, and we focus on network security because as we know, um, a safe computer is a disconnected computer, but a disconnected computer loses almost 90% of its usability. So whenever we will think about securing our computer, it's always we are thinking about network security, right? So what's the current state of cybersecurity right now, right? Then we look at who are these threat actors or the perpetrator of all these cyber crime, right? And then we look at the tools utilized by these actors, like threat actors. And then we look at malware as a category. We describe what are different malware types. We also look at what are the common network attacks. That means very typical network attacks, right? We're not looking at there are some network attacks, okay, that is less well known, not because of it's not that threatening, but uh, it's because in the wild, that means in the wild means on the internet, it's not really popular, but being used by threat actors, but they exist, right? Some network attacks are proof of concept still in the lab. Okay, network security people actually testing it out and they discover and then they report, right? But we are looking at the common ones that already been done and still being done. Being that means it's being used by threat actors. Okay, look at IP vulnerabilities and threats. Okay, IP vulnerabilities. A lot of these vulnerabilities should be covered by IP version 6. Okay, when we start using fully IP version 6, but IP version 4 was created without consideration for security. Okay, because it was invented at a time when the network was small, the internet was small, and people are more interested in, and it's localized lah, right? And people are more interested in sharing information rather than trying to hack into. Once Especially once the internet becomes a source of commerce, not only for transfer of money, but also for doing business, lah, right? Then other threat actors appear because there's money there, right? There's money there, right? And it start to become very vulnerable, lah, right? IP become vulnerable because it was not designed for that, okay? To stop threat actors. Then we look at the two layer 4, okay, transport protocols vulnerability, TCP and UDP. Okay, so even at this layer 4, the IP vulnerabilities exist at layer 3. So at layer 4, we also have vulnerabilities. Okay, especially with TCP and UDP. And then IP services. What services? One example service is the ICMP. Even that can be exploited by the threat actor. In fact, ICMP implementation is ping, right? It's actually very useful for us to troubleshoot our network. But the thing is, the same discovery that we use ping can also be used by threat actors, but for different purpose, right? And then finally, we look at network security best practice. Okay. Right, let's look at current state of cybersecurity. Now, while we go through this, there will be a few videos that I really urge you to look at. The videos can be found online. I'm not going to show the video to you because each well accumulation of all the videos will just um, reduce our time for the lecture. But you can view them on your own, right? As part of your revision for this lecture, this topic, you can view it. Okay, there's a few there. You can get it from NetAcad. You can just stream and watch it. It's quite useful also. All right, so cyber security involves cyber criminals. We call it cyber criminals because these special kind of criminals are active online, right? Okay, a lot of the criminal no longer physically rob a bank or or let's say do conduct physical crime because physical crime is very messy, very dangerous, can be fatal for them as well. So they saw an opportunity to conduct crime online, right? Where it is harder to what lah to track sometimes. That's why for infosec, one of the things you learn is to do forensic, right? That means to collect evidence and also to collect evidence to find out what happened, right? Just like in a real crime, the evidence you collect must be able to stand out in the courtroom, lah, right? So that when you show your evidence, that's beyond doubt the perpetrator has done something criminal, right? The thing is now they want to do crime online already, and they can easily do. If you go to a bank and you say I want to steal 5 million, I think for Hollywood movie is great. Oh, I stole 5 million, but have you ever considered how much 5 million in paper money weigh? It's very heavy to carry. It's very it's very hard to you know to use also, unless you want to buy everything in cash, and it's you can then rob a bank and carry out 5 million and then start spending or start putting back in another bank. You easily caught. But dealing with digital currency, okay, I'm not talking. It could be, but I'm not talking about the cyber currency, the cryptocurrency. Sorry, well, I'm talking about normal currency, but digital form. It's easier. It's just a flow of electrons, and you have transferred, you have gotten away with the robbery, right? Right. So they basically, in order to do crime online, they need to get this expertise and tools. And if the criminals or mafia or whatever do not have the tools, they will hire someone who has the expertise, okay, and the tools. Tools here means software tools, right? That is necessary to do the criminal activities, right? And it's a constant fight between infosec people, information security people, and these cyber criminals, because as a cyber criminal invent new ways to do this to do this cyber crime, infosec people also is trying to come up with tools to prevent, also tools to carry out forensic work to catch them. So it's a constant battle, right, between these two groups of people. All right. So the tools and techniques continue to evolve. Okay. Right. For example, our Wi-Fi. We start with WEP, but criminals able to crack it. Then we come up with WPA. Again, criminals able to hack it. Then we come up with WPA2. Criminals able to, well, potentially hack it. Then now we have WPA3 coming in the works because of that. So it's always a constant battle, right, between the infosec and the criminals, cyber criminals. right? Okay, so all users should be aware of security terms. These are terminology, right? How we describe this specific terminology when it comes to security, our IT security. So we must understand. So when we say as assets, assets are anything that is of value to organization, right? Whereby it can be people, it could be equipment, resources, and data. These are the assets of the organization, right? Vulnerability means there's a weakness in the system, whether it's design, right, or its operation or its current state. Okay, and if this weakness is known, then it could be exploited, right, by any kind of threat lah, any kind of threat the cyber criminals can impose. So vulnerability is just a weakness, it's there and waiting to be exploited. So if you have a vulnerability, what you want to do is you want to remove that vulnerability. Okay, if the vulnerability because your OS has a serious flaw, you have to do something by patching the flaw, thereby removing that vulnerability. Threat is a potential danger. So again, this potential danger is danger to the company's assets, right? Data and network functionality, right? Maybe they want to deny your customer out of your network or your own employee out of the network. Okay, okay, potential danger. Exploit. When we see this term exploit, this exploit is that mechanism or algorithm or technique that is used by the cyber criminals to take advantage of your vulnerability. Vulnerability is a weakness. Okay, so to use this weakness, there is a technique. So that technique is called exploit, right? So exploit is a mechanism to take advantage of the vulnerability. So to block this exploit, you need to get rid of the vulnerability or reduce the vulnerability. Okay, so mitigation is what you do, okay, to reduce the vulnerability. That is called mitigation. It's a countermeasure. Either you remove or reduce your vulnerability. Okay, so sometimes it's one mitigation, but sometimes multiple mitigation working together, right? Right. So risk is what? Risk is the risk of this vulnerability can be exploited if you don't take mitigation, right? So risk is the likelihood of a threat to exploit the vulnerability of your asset, right? Okay, so all these are actually terminology in information security. Right, so data loss. What do you mean by data loss? Well, literally, data loss could be loss of data if you don't have backup. You lose your data. Sometimes data, when you lose your data, you lose your business. Can you imagine a company, a bank that has credit card customers and the credit card use transaction information is lost? How are they ever going to collect back the payment, right? So data loss directly translate in this example directly transfer to loss of income, loss of money, right? Imagine transaction is lost. How can you then prove the customer has any transaction? Then how can you claim the customer to pay back, right? So data loss. Oh, this extreme lah. Exfiltration means data is lost to someone else, right? Leak to the outside world. So I think this is obvious. Can we just list it out? If you caught data loss as an organization, your brand can be damaged. I mean, say if you know that bank has been consistently been hacked, they cannot protect their data. Are you still confident to store your money inside the bank? That's why a lot of bank institution, financial institution, even if they lost, they claim back insurance lah. But even if they lost, they will not report it. If possible, they will not report because they'll try to cover up. Not because of what? Because they are scared of this brand damage and loss of reputation. Once you lose that, if your business is based on trust, then you're in big trouble, right? Not only you lost money, you lost data, but you also lost this one, right? Oh, that's bad. Sometimes the data is your competitive advantage. Maybe it's the design of a product, okay, and only you have that design or whatever it is. So if it's lost and it's leaked to the outside world, everybody else can see. Not necessarily they will copy it, but they will design something similar to it. But they're not using your process, they're using different process. But you already lose your competitive advantage, right? Then you loss of customers. That means your customer list, your customer information, credit card information, your customer leave you in rove because of loss of trust, loss of confidence. Then you lose customers as well. Loss of revenue, your source of income is lost. This is what I'm talking about. You lose your credit card transaction information, right? Example. Then there's a problem of you being sued. If the data loss involve your customer data and your customer get very angry and then they want to sue your company, then you face that litigation, legal action, which can result in a very huge amount of fines and civil penalties, right? If you're big enough and you have billions of dollars, then maybe you can absorb. But if not, then it can bring bankruptcy to your company, right? Significant cost and effort to notify affected parties and recover from breach. Now, what happens if, let's say, Facebook, right, got hacked and a lot of the information is stolen and leaked out? Now, Facebook has to do a damage control. That means um, they have to go all out to notify each and every identify first each and every single customer who's got the information stolen, and then uh, you know mediate how to protect them, how to what to do after that, the damage controller basically, right? So a lot of things have to change. Their security protocol, their provisioning, security provisioning, all have to change, right? So there's a lot of cost involved, right? Not only the previous litigation, legal action, but cost to meet to mediate all the customers, right? To pacify them, so that they don't sue you or whatever. Ayo, right? Right. So we use network security professional to protect our organization from any of this, right? So in a combination, normally the implementation includes to combine strategic, operational, and tactical measures, lah. Right. So the data loss factors. What are things that can lose data? So email, social networking. Just now I talk about um, Facebook as social network data. We store a lot of our data there, and most of the time we share, but some of it we don't share for our own consumption or consumption of our immediate families. We don't share to the public, for example, right? We always see some leak photos, leak videos, things like that, right? From social network, the cloud storage, right? Cloud storage device, right? Email, your email could be harvested and sold to, you know, a third party who want to do spam advertisement, right? Okay. Unencrypted device. A lot of people do not use encrypted device. For example, we know for a fact that Windows, the Pro version, whether 10 or 11, actually have BitLocker, right? So that means if the if you don't encrypt your data, let's say you cannot log in, but I can open your hard drive under an editor, hard disk editor. I can still access unencrypted content. Then I can just rebuild. I have a sophisticated software. I can just read out from your hard disk. Even though I cannot access Windows, I can still get all your data which is stored on the hard disk. It's not encrypted, so I can do that. As long as I have physical access to your hard drive, I can retrieve all your information. I don't have to log in into your Windows or OS to get your files. I can just open it up, physical, read sector by sector, copy it into in raw format, go into another and a software can just identify, oh, this is Word, this is JPEG, this is what I can see already. So the way to mitigate that is to encrypt it. That's why you got BitLocker, right? For Windows, it's only available on Pro version, right? You enable BitLocker, at the device driver level, every information you write to the hard disk is actually encrypted. And then, of course, every time you read from the hard disk, Windows will decrypt it first. So that means, let's say someone have access to your hard drive, they want to read, they cannot, right? Because it's encrypted. BitLocker, the technology. So data loss from unencrypted devices, right? Very simple. Nowadays, it's actually partly software, partly hardware based, so you don't even feel the difference lah. It's quite fast to do this, especially on SSD. Hardly any lag, even if you encrypt, right? Removable media, because it's portable, it's removable, it's easy to lose it, right? Right? Easy to lose it, or easy to be bring in, copy something, bring out again. It's portable, right? Hard copy is the traditional one lah, right? You always see this, even Hollywood movie. Let's say you want to hide something, you shred all your hard copy, so cannot be easily read. But painstakingly, it can still be assembled, but it's very long process, tedious process. But as much as possible, the only way actually to shred really into small bits. So it depends on your shredder lah. Your shredder is the good one, then it cross shred. Cross shred in one direction, maybe vertical, then shred again in horizontal. So it really does produce very tiny pieces. It's very difficult to assemble back, right? For hard copy, yeah. Improper access control. Access control is someone want to access something, then you ask to authenticate first whether you allow the access or not, right? So typically we use password, right? But password is, in general, is not good, because in general people have difficulty remembering password, especially if all access require you to enter password. So let's say you have 10 logins, all 10 logins will need password. If you use the same password for all 10 login, then that's actually very dangerous, because one password is cracked, all 10 logins will be compromised. But if you have a different password for each login, then all 10 logins, you have 10 password to remember. And usually the password cannot be simple. If you have simple password, people can guess, or dictionary attack can be conducted. So can you imagine combination of numbers, letters, symbols for each password? Then you have to memorize all 10. That's why that's why I said password is actually not very good, because what that will do is people will start to use weak password because they can't remember the password. or they just write down the password and on a post-it note and put it somewhere close, right? Right, so let's look at threat actors. The first threat actors are, this are very popular in the media, right? The hacker, right? And it's when it is originally not a very bad name. Hacker was used to describe in the 80s. Used to describe someone who is very curious, technically very gifted, is able to um, do things lah, right? Like penetrate system, and they penetrate system for learning purpose. Last time, hacker is not the connotation of the word hacker is not that lah. But now, due to also popularity from media and also movies, hackers now is used as a term to describe a threat actor. Okay, so because of that, we differentiate between three, right? So to make it more clearer. So the good hackers, those are ethical hackers. The original usage of hackers to describe someone gifted who can penetrate system and do but not do harmful things, right? Are called white hat hackers. They are ethical hackers, hackers that has ethics, where they use their knowledge just for learning purpose, but for good purpose. So in fact, they do try to find out security vulnerabilities of your system. But once they find out, they're not going to use it for criminal or unethical use. They will inform normally the owner of that system in order for the owner to be aware of it and try to mitigate or to fix, right? And some white hat hackers do this for a living. They do those and then they claim bounty. A lot of organization actually offer bounty, huge amount of money. If you can find any vulnerabilities and you report to us, and then if we find that it's true, then we will thank you and give you a lot of money, and then we'll fix it, right? It's better that the white hat do this for us rather than the black hat, right? Okay, so there are a lot of people making living on this lah, right? As a white hat hackers. Gray is somewhere in between, right? They might do unethical things, but not purposely for their own personal gain. That means they don't earn money, or they don't intend to cause damage, right? Okay. But some of the things they do, maybe they okay, let's say they don't inform you, they enter your system, so that by itself already constitute as, hey, come on, you're not authorized to enter my system, but once they enter the system, they tell you, oh, you know what, you know why I managed to enter your system, because this is, they inform you, right? But in the first place, them entering your system is already sort of like gray areas, right? Sort of already not so legal lah, right? Okay, and then we have the extreme end, which is the black hat hackers. These are criminals. They really do it for the money, for their own personal gain, or for malicious reason, right? Whether it's for money, ideology, they want to impose their ideology. They don't like you, okay? They think, okay, they think that your company is producing too much carbon dioxide and you're killing it, and then they go and DDoS your site, distribute denial of service your site, or they go and chonteng your website, right? These are considered already criminals now, right? Even they hide behind, oh, because you know what, you'll be a bad company, right? Okay, so but most of the time we actually meant those mafia, those mafia. The criminals, for example, in Russia, they hire very highly technical gifted, uh, you know, computer person lah, right? And then to do the hacking for them, right? All right. So let's look at under evolution of hackers. These are modern hacking terms, right? That sometimes you read online. Script kiddies. Script kiddies are kiddies represent young teenagers, or they just know a little bit, but enough. They are inexperienced. They're not very technically gifted. A little bit lah, right? But they are able to do certain things because they have access to tools, tools to share among them, or they get somewhere, and then these tools are normally very sophisticated, right? So maybe they got the tools, they don't really know how to create the tools themselves, right? But they don't really know how it works. They know a little bit, and then but they know how to use it, right? So and then they will use it. So you can see, okay, they basically go to hacking website or hacking forum. They saw a copy of the script, they download and then they use it, right? Okay. They normally don't do it for profit lah, but just to show off, maybe show off they're able to do it, something like that, or for their own ideology. Vulnerability broker, they are gray hat. Okay, so they this is what I described earlier on. They discover, exploit, and report to vendors. Okay, sometimes for prizes or rewards. Hacktivists, they are the ones that are protesting. Remember just now I said, oh, protesting against a company because the company is not don't care about carbon emission, so they're considered bad, bad company because they harm the earth, and so they are activists, but they use the computer to show their displeasure, right? Okay, so they post articles, video, they leak sensitive information about your company just to kasih kena your company, or maybe they even perform network attacks. So they sometimes do gravity on your homepage. Okay, then they are cyber criminals. They are self-employed or working for large crime criminal mafia, right? Traditional mafia now move into the cyberspace lah, kind of because it's more lucrative for them and safer, right? And then we have those state-sponsored, right? Sometimes we call them state-sponsored terrorists because what they do is the government conduct cyber warfare or cyber intelligence, right? Sabotaging, influencing, right? Gathering intelligence, right? All this. So we're not just talking about countries that is obvious like Russia, North Korea, but China, but also the Western. The Western countries also do this lah. They have their own, sort of called hackers lah, to conduct cyber warfare, right? So in Malaysia, we call them cyber trooper, right? They probably don't do any hacking, if but they do release a lot of fake news, trying to encourage people to change people perception, right? Cyber troopers, like we call them, right? Okay, so let's look at the tools used by threat actors. So again, please follow through this on NetAcad Online to look through the videos. Yeah, I'm not gonna show the videos. I'm gonna skip them, but I expect you guys to have a look at the videos yourself. All right, so a threat actor usually will use a learn technique. Either they learn the technique themselves, create the technique themselves, or got it from somewhere else, or they use specific tools. Tools here, uh, most probably software tools, right? So more over the years, the attack tools become more sophisticated and automated. That means you don't even have to um, do a lot of, just upload it and then wait for the tools to activate. and then it will be autonomous, right? So these new tools are so easy to use that you don't really need to know even programming to use it. That means you don't need to know technical knowledge to use these tools. You just run it, and that's it. You get the result, right? So here we can see penetration testing tools, because InfoSec people also use these tools to test the vulnerability, security vulnerability. And if you're InfoSec, you know about Kali Linux. Kali Linux is a distribution of Linux which contain this and a lot more tools for pen test. They call it penetration testing, or pen test. Okay, so let's say you want to test the best way to test security is to attack the security and expose any vulnerabilities. So these are just a few here, and the second slide after this is password crackers. Basically, these tools use either very brute force or very clever way to uh, basically extract the password, right? So some example will be John the Ripper, Opcrack, Lobcrack, Hydra, Rainbow Crack, and Medusa. The names sometimes reflect what technique they use, sometimes it doesn't, right? And they are no some of them are just brute force attack. Some of them are dictionary attacker. That means attack to crack the password lah. Some of them use sophisticated algorithm. Okay. Then we have wireless hacking tools, Aircrack, NG, Kismet, in SSIDer, Kismac, Fireship, Wistumbler. These are just some of the tools available, right? So if you want to test whether your Wi-Fi access point is vulnerable, you use this, right? So some of them are not just Wi-Fi; it can also attack Bluetooth, right? Bluetooth to attack your phone. All right, so to gain access to your phone. Then we have network scanning and hacking tools. Network scanning, scan for what? Scan for open ports. This system probe the port of your network, your computer, which one is open, right? And when they find out there's an open port, they will see whether there's any vulnerability for that port. If you're not careful, you might have missed there's an announcement earlier on about this port vulnerability on what you didn't patch your server, then they can utilize that vulnerability, mitigate. Normally, the mitigation is you keep track of the latest security announcement for your server and implement the patch as soon as it's released to basically plug the hole, right? Okay. And then there are Nmap, Superscan, Angry IP Scanner, NetScan tools. Some of these are basically networking tools, yeah, for us to do troubleshooting, right? Because sometimes we want to find out why our network doesn't work, so we use these tools also to find out. But hackers can use these tools also to find out whatever working, not working, but in terms of security vulnerabilities.
Are these tools free or
They are free.
uh,
They are free. You can search in Google, and you can actually, I think some of them are available and you can download. Those not available are those used by government sponsored one lah, like NSA. Okay, NSA, they have very very clever hackers, right? And they have tools that can even take over your Samsung webcam on your TV. You know, some of the Samsung TV got webcam, right? They can basically take over it and look at you watching your TV. And I'm not joking. They have tools to do that. But whether you can download those kind of sophisticated tools is a different matter. They want to eavesdrop. They don't. It's not like James Bond anymore. You have to place like a listening device. They can hack any of your device in the room then they can activate remotely, then they can eavesdrop, right? They can hack onto your phone, right? They can activate without you knowing. Some phone, due to how to say this, they can detect vibration. When you type your password, if they hack your phone vibrates. Your phone is beside the keyboard. They can translate that vibration to what key on the keyboard you type. There are some very, very sophisticated tools out there, which may be difficult to find unless it's leaked. But these are the common ones. This one you can find online. Very easy to find online. Okay, is that okay, Kelvin?
Okay.
Right. So, and then you have packet crafting tools. This one, um, you can basically it's like an editor. They can tick 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 which one, which type of head information, the header or the packet you want to change. You can edit lah, right? And then you can then use it to send and test, right? Remember we use Wireshark. Wireshark is also very good for us for diagnosing our network by looking at by just capturing even frames or packets not belong to us. We can still skip it using that kind of tools. But the hackers also can use it. Not only that, they can once they capture the what and they can investigate, they can then send a reply, something like that, and then they could manipulate lah. They can manipulate what should put inside the fields or whatever, right? So you can craft a forged packet. So some tools like HPing, Scapy, Copcats, Senior, Netcat, Nping, Nemesis, all these tools available actually online, right? So if you're a normal network security network administrator and you don't learn this security, you know, pen test tools, then how would you know so normally either you go and take a certification, then you know all this, or your organization, you focus on network administration, networking. But there's another. They will hire someone who good in the pen test to test your system. And of course, this pen test expert will, after their testing, maybe you give them few weeks, they will come up with a report, and then they'll tell you all the vulnerabilities. Then you pay them, then you can mitigate lah. Then you ask someone to go through the list of vulnerabilities and fix it, plug it, right? Packet sniffers is like the Wireshark lah. And the packet sniffers here is basically same as the simulation mode in our packet tracer, where we can open up a frame, a packet, at which layer we can see content. We can see the field header. We can see that if not encrypted, we can see the data inside it, the payload lah, payload of the frame, any layer you can see. So this is called packet sniffers, right? So see, you can see that the tools that we use in FCN before Wireshark is there, but we have others: TCP dump, EtherCap, DSNIF, EtherApp, Paros, Fiddler. Fiddler is actually not a hacking tools, just like Wireshark. It's actually a good utility, but it can be used. Okay, it's just a tool, you can use for good, you can use for bad purpose. Then we got red proxy and SSL strip. If you from the name, you can see a secured, the HTTPS. You can strip it out. I don't know how they do it. I have to look at it. And then some more rootkit detectors. Rootkit basically something that can be inserted, a software that can be inserted into your OS, right? In fact, the most famous is the Sony Rootkit. Sony actually quietly, the moment you insert a CD, audio CD last time, You insert the audio CD into your computer, the rootkit automatically execute and embed itself in the OS. Why Sony do that? Because once it embedded in your OS, excuse me, every time you want to copy a CD, the rootkit introduce an error. So basically, you cannot copy Sony's audio CD. But someone found out, and that someone complained because what Sony is doing also unethical. Without any permission, go and insert something into users OS and basically do something that like a nearly like what a hacker will do. So it was a big hoo-ha lah. You can search Sony Rootkit quite a while back, but it's one of the example that company also can act unethically, okay, to protect what they think is there. What that time no Spotify, only audio CD, and you tried a lot of people thinking like this. I bought your CD already, so why not? I can just copy it. It's mine also. But actually, it doesn't. The license doesn't work that way. So Sony want to impose this kind of rootkit to prevent you copying their audio CD. You guys can go and have a read, yeah. Rootkit. Okay, and then fuzzes are used to search for vulnerabilities. So basically, it someone write this software and put in all the different types of security vulnerabilities. Now, the thing is, it shouldn't work because if all sysadmin and network admin will maintain to vigilance in looking for vulnerabilities, whenever a vulnerability is announced, there will be a patch. Okay, whether it's in Linux or Windows, and then all you need to do is follow the instruction, update the Windows, update whatever to patch vulnerabilities. But sometimes, and most times, they don't do this. So this second thing works in the sense that people don't do it, don't update to patch the vulnerabilities. So to make it easier to search for vulnerabilities, they just load a lot of the vulnerabilities detector inside the software, and then they just run it, and it will tell you, oh, this one is vulnerable to this. This one is vulnerable to this. Then you know already how to attack the computer, right? And then forensic tools are basically a tool to find out what happened. Actually, it's already happened, but in order to basically to get on the trail of the cyber criminal and also to collect evidence, then you need forensic tools. Okay, because the evidence sometimes once you catch them, you have to prove in court, right? So unless you have very strong evidence, then it's sometimes very hard, okay, to get them in court. So we use forensic tools to capture evidence lah, also, right? Just like the CSI to collect evidence in real life. Digitally also, you can have forensic tools to collect digital evidence. Okay, and then we have debuggers. Debuggers always very useful. It's not only for debugging codes, as you know already. You guys are taking OS. I think OS has not OS. Computer organization, right? So one of the things you learn about is debugging assembly code. All source code may not be included, but all executable can be converted from machine code back to assembly code or symbolic code, right? By using debuggers. Then if you are available to, you have the knowledge to read through this, okay, you know about symbolic code or assembly code, then you can basically debug any program. And when you debug, you can then see how it works. This one, the IDA Pro, is very, this one is paid, I think. I think they have the light version, but the paid one is very, very good. A lot of crackers use this disassembler to disassemble software application, DRM, and also DRM in not only application but games to remove to crack it so that it doesn't ask for any no DRM again digital rights management anymore right? Okay, but sometimes white hat also use debuggers to analyze malware. In case in point, the WannaCry, it was stopped because a white hat researcher analyze it, debug it, debug, and go through, trace the code inside a sandbox. Sandbox is like a protected environment, like virtual OS and then run it inside, and then where you can basically run it without worry right? And then debug, and then found out something that can stop the malware in its track, right? Hacking operating system. Oh, that's why I mentioned just now. If you're a pen tester, you should download Kali Linux because that kind of distribution can be run from your pen drive, right? And it has pre-installed a lot of the tools that I mentioned earlier on. Tools very valuable to do forensics and penetration testing. Okay. Encryption tools to encrypt. So VeraCrypt actually is the open version of another older version. VeraCrypt allow you to create virtual disks from your current hard disk, but you will encrypt it. So anything inside you don't want to use BitLocker, you only to encrypt certain files, then use VeraCrypt. VeraCrypt will ask for you to create uh, a, a logical drive out of a file, maybe 2 gig, 4 gig, up to you. And then in order to open that drive is just like a virtual box drive, right? Then you have to enter a password. If not, then you cannot access. Then it's sort of like a secure storage inside your drive, right? Then you have Cypress shared, OpenSSH, OpenSSL. OpenSSH, already a secure shell, right? And then you have Tor. Tor is a browser that hides you from the anybody wanting to know what you're searching for or you're on the browser for. And it also open access to the dark web because you want to go dark web a lot of times the content there are criminal content, so you want to protect yourself so nobody knows you're going into the dark web. Then Tor, in order to access the server, it basically bounce your IP around. Okay, that means you go to different computers online as proxy, right? So I think you can download the Tor base. The browser is based on Firefox, I think, right? Last time I checked. Then you have OpenVPN, virtual private network, right? This software allow you to route your network from your computer via a virtual private network again to encrypt and to prevent anybody to eavesdrop on what you're surfing on, right? And S tunneling again, same as with virtual private network, is encrypted and hides you. That means you can even for tunnel you can even use a different port, and you basically tunnel inside the port. In fact, your application use different ports, but you tunnel inside a different port to hide your what do you call this your network messages, right? Then you have vulnerability and exploitation tools, Metasploit, Core Impact, SQL Map, Social Engineer Toolkit, NetSparker. right? These tools identify the remote host, whether it's vulnerable for a specific type of attack, right? And then basically, depending on which vulnerability, then it will use that vulnerability to attack the system, the remote system. Okay, another some similar that one, detect and exploit. This one is to scan for the vulnerability, right? That means it can scan which port are open. That's why it's always encouraged that if the port is not used, close it. Okay. They can scan for known vulnerabilities and scan VMs, bring your own device and client database. So Nipper, CoinPack, Nessus, Saint, and OpenVAS. So these are some security tools, right? And then we have a look at attack types. Attack types, I think you're more familiar. Eavesdropping attack simply means man in the middle. You got to capture and because when you capture, the original message is still forwarded, right? Just capture a copy of it, of that message. So nobody knows that you're actually listening or sniffing or eavesdropping, right? Because the destination still receive a copy of that packet. Data modification attack, they capture traffic, but not only they just listen to it, they can do extra, which means they can alter and forward. But the thing is, the receiver don't know about it because it happens in the middle of the transport. Sender also don't know, right? So not only this drop, but you capture and modify the packet or the frame, whichever PDU that you want to modify. IP address spoofing, basically, um, you spoof the IP. That means you create a packet and make it seem like that packet you create comes from a legitimate computer or host, right? And then password-based attack, basically, um, they try to get your password lah, because if they can get your password, then you are authenticated as if you are the real user. Okay, and then you have all the users right. Okay, so then they use that users access to access other things that the user can access. So obtain list of other users, what is the network topology, change the server network config, modify, reroute, or delete data, things like that. Then when you're doing forensic, you see as if the real user is the one doing it, but actually the real user logging info, the password already stolen or already cracked, right? To hide the real attacker. Then we have denial of service. Denial of service simply means overwhelming the host so that the legitimate users cannot access the service because the host is too overwhelmed already. Okay, and usually we put D in front. The distributed means a lot of these are legal requests actually, but it's just a flood of legal requests that it overwhelms the server, right? And man in the middle attack, the threat actor position themselves between source and destination. Then, very similar to eavesdropping is now, they can monitor, capture, control the communication. Compromise key attack, the threat actor have, I don't know, there's another way for them to get, but they can get the secret key, right? So that key now can be referred to as compromised key. Then they can use that key to gain access to secure communication without the sender and receiver being aware of the attack, right? Then sniffer attack. Sniffer attack means the application or device can read, monitor, capture network data exchanges, and read network packets like the Wireshark. This is sniffer attack, right? If you don't use any encryption, right, secure HTTPS, then they can see whatever content inside the packet, right? Just open up the data part and read off the content. Okay. All right. So we are basically just a quarter, I think, 17, 20, 80, a quarter into the network security, right? Right. So let me just check quickly. All right. So before we proceed, I think we can proceed after a quick break. I've already shared the tutorial for last week. Okay, and I think I'm in the middle of marking your first week's and second week's tutorial. So let's take a break first, and then after our break, we'll continue. And then for the tutorial, we um, will do as homework for this week because I think we are a bit behind on this security lah. Right, so let's take a 10 minutes break. We resume at 10 past 3. Is that okay?
Okay. Okay.
All right. Noel, okay? Take a break first. Hello everyone, welcome back. All right, so we'll continue with this lecture. I will upload the OSPF tutorial and you can do as homework later, yeah. And then we'll find some time to discuss it during tutorial session next week. All right, so in the meantime, we'll try to complete this 3.4 malware. Okay.
Okay.
Okay, so malware and basically software that is have intention to create havoc on your system to basically what the payload is depending on what the writer of the malware intended, right? But usually it's to do something harmful to your computer systems, right? But no user intentionally download malware and install it now. So basically, they trick users to install or unknowingly install malware, right? So we have different types of malware. We have the traditional virus. Okay, it needs to have a point of installation where the virus can then spread from there, right? So virus spread by infecting other software, okay, and they spread in that manner, lah, infecting other software, and then that software, infected software, is then executed, and the virus will propagate. Okay, but virus, in order to propagate to different system, needs to be copied. Okay, infected software must be copied before the virus can execute in other system. Then the virus will then infect other files executable in that system. Worm basically different from virus because worm can make use of network connection to make copies of themselves. Okay, they do not need to infect other executable. Worm has the ability to travel via network to infect other system without infecting files or executable. And Trojan Horse basically uh, software that pretends to be useful software, but inside it hidden some part of the code that provides some harm to your computer, right? So you can see virus hides by attaching itself to computer code. How does it attach? Usually, when you run executable, there is a beginning of the code, right? That execute first because of the nature of your code that is running in sequence. Basically, most virus, they attach a simple header at the front of your code, which when executed will go to usually to the back of your executable, right? And then execute there. And this part of the virus is the one that performs infection and also load itself into memory, okay, into different part of the memory. And then after it runs the part of the virus, it will then redirect back to the original computer code and execute the computer program as usual. So a lot of times users are not aware that the virus already executed. Okay, so the infection part of the virus perform this, but there's also the payload part. So the payload part is triggered by whatever the writer wants to be the trigger. Okay, so once the payload execute, and that's the part that may cause problems into your computer, corrupting your hard drive or deleting files, right? Or even stealing information and forwarding it somewhere, right? So you can see that it can alter, corrupt, delete, or erase entire drives. Okay, a specific kind of malware is called the ransomware, where it actually encrypt your entire drive, thereby stopping you from accessing your files. And usually ransomware is called ransomware because it asks for payment in order to unlock the encrypted drive for you to be able to access your data again. Right? For viruses, viruses can infect not only executable but also the code that is used by your computer to boot up. So sometimes it can cause boot up issues lah, problems, right? It can the payload can cause these harms, or it can just keep quiet, capturing your keystroke, capturing going through your files and sending information to outside your PC via network. Okay, there might be a specific host outside there on the internet where this virus connects to that computer. There's maybe a server running there, and then send files over, send information, keystroke, or even streaming videos, right? It can also access your email accounts that means once it infect your system, it can access to your email accounts and password. Then it can automatically create an email. Okay, and this email seems to be from you or from whatever that is very attractive for the recipient to open up, to trust it. Okay, and then it can attach itself as an attachment, okay, to the email, and that is one way for it to spread also, right? It can lay dormant. Lay dormant means it doesn't exhibit any external indication that it's already infected your system. Since everything run as normal, you don't have any cause for alarm, only until the threat actor activates it, send some kind of signal to this dormant software, whereby it will wake up and then do whatever the threat actor intended for it to do. In most case, it is actually turning your computer into a bot, and then your computer, the software, the virus that is already inside your computer, will then activate and send and is using your computer to DDoS a particular server online, right? So you become one of the distributed computer that perform the attack. And this is very hard to trace back, because there could be several months until between you got the infection until it activates. And when they try to check back who is causing the DDoS, they will get back to your computer. And if there is no trace of how your computer got infected in the first place, then basically the trail ends there. And then you have a very hard time to explain also why your computer is attacking another server. Okay, a lot of unknown victim find out their computer is used as a attack vector to attack other DDoS attack perform a denial of service attack, right? Right. So a boot sector virus are viruses that infect a boot sector. So every time your hard disk boot up, and it could be also the boot sector of a pen drive. So every time you boot up your hard disk, or if you switch off your computer and you forgot the pen drive inside, right inside the USB port, and sometimes your motherboard is set to boot up from the USB, if not from the hard drive, then the virus automatically executes. Right? It can attack boot sector, your file partition table, or file system. Firmware viruses attacks your device firmware. That includes your BIOS. Your BIOS can be infected also, right? Okay, but it's a more sophisticated attack if it's a the BIOS firmware. Then we know that Office application has macro capability. That means it can run scripts, and these scripts provide extra functionality, whether to your Word document or your Excel spreadsheet, and this kind of viruses is actually run inside your Office. So when you open your Office, the macro is executed and it's a macro virus, and then it infect other Word document, but it also has payload. And when it's executing, it can delete files, or snoop through your files, or etc. etc. Okay, so that's macro. Macro runs under Office. Okay, sometimes it's VB script, sometimes it's C# script. Most probably it's VB script. And then you have program viruses. This one infect an executable. Okay, other executable. So you need to be able to copy the infected executable file to another computer to infect the other computer, right? And of course, apart from programming languages, you have scripting language also. So that means viruses can also be written in scripts, right? So it attacks your whatever your interpreter lah for that script. So maybe Python, right? It's like a script, or bash on Linux terminal, right? And then we have Trojan Horse. Trojan Horse pretend to be a valuable or useful program, but hidden inside is a piece of code that actually do something harmful lah. So these harmful things that you can do is, for example, remotely accessing another uh, host, right? Sending data it collects, okay, such as password, login name, password, can be destructive. It can corrupt or delete file, and sometimes it's very insidious where it doesn't really delete consistently. Okay, it corrupt time to time. It corrupt a different piece of program. So you never sure whether it's your hardware malfunctioning or is it actually a Trojan horse that's doing the corruption. Because hardware corrupting your files also can happen. Maybe malfunctioning RAM can sometimes corrupt file, because of course the data is stored in RAM first before it's written down to files. And if there's a corrupted bits in your RAM, then your file will be corrupted as well. Okay, so and if a Trojan horse is also very selective or randomly corrupting, then it's very difficult to differentiate unless you run a virus scanner, a Trojan horse scanner. You scan your system and it detects the signature, right? That's why it's very important to have an antivirus or anti-malware protection for your system, right? Proxy here means the Trojan horse is actually using your computer as the platform to perform an attack to another computer, because the hacker do not want to be traced. If they are using their own computer to hack or to perform something illegal, then very easily their computer can be traced, right? But if they use your computer, they upload the Trojan horse into your computer, or you download and install into your computer, and then the Trojan horse is actually hiding a functionality to attack another computer. But now they trace to your computer, right? Instead of the original hacker, right? So FTP, then Trojan horse will basically file transfer, okay, perform a file transfer using FTP, yeah, which is actually unauthorized lah, right? Okay, so it will open up as an FTP server, allowing the threat actor to download. Remember, FTP is actually a file transfer protocol, right? If there's an FTP server, then FTP client can access your hard drive to download whatever is shared. So if the Trojan horse runs an FTP server and open up the whole drive to be transferred, okay, and then an FTP client run by the hacker can then connect to that FTP server that actually created by the Trojan horse and start downloading your files, or even upload more Trojan horses or other malwares, right? Trojan horse also can work against an antivirus program. This is the initial activity before performing other other things, because it detects that you're running antivirus software. It will disable your security software in order for it to do other more serious things, right, inside your system, right? Trojan Horse can perform denial of service attack, can also log your keyboard keys. Whatever you press on your keyboard will now be safe. So whatever it is lah, whether it's confidential documents or you're using your computer to do online banking, it now captures your password, for example. Right, other types of malware, adware. So when you download software, suddenly you find a lot of pop-up, a lot of advertisement now popping up, not only in your browser but also in your system, right? Your system is now periodically popping up advertisement to you, right? Unsolicited, because you didn't click, it opens up and then you can see it. And then this is very difficult and tedious for you, because it pops up everywhere. And then it basically, when it pops up, it is in the foreground, hiding whatever you're working on. And you close it, it opens up again. You close it, it opens up again. So this type of adware is very frustrating, right? Right. I talk about ransomware already, right? Usually they asking for cryptocurrency because it's very difficult to trace. Okay, and this is quite recent, only during the last few years, because of the popularity of cryptocurrency. Okay, so some organization are willing, because especially if they don't have data, or the data is incomplete, or data are also corrupted, they have no choice. They want their data, and data actually represent their business. So they are willing to pay, right, huge amount of money in cryptocurrency. Okay, cryptocurrency doesn't belong to any banks, so there is no way to trace if you're going to operate. I mean, withdraw the money from the bank, it's will be traced very, very quickly. So they don't use banking, they use cryptocurrency exchange. Okay, Rootkit, I talked about it already. Well, I guess, have you guys searched on Sony Rootkit? Okay, that's an example, right? But other types of rootkit is basically because it patch into your OS, yeah, most of the time, right? And they rename themselves as if they are valid part of your OS system files. And then it's very difficult to scan for this. And then they will sometimes create backdoor, so that you're using this backdoor, the threat actor can then connect to your PC remotely, maybe even take control of your PC, right? And because it involves them patching into well-known operating system files, okay, you need to, and rootkit can be very specific. You need to know what kind of rootkit it is, then you need to know what kind of replacement to replace the rootkit with the original OS, okay? So sometimes if you can't remove the rootkit because it attach itself to important system OS files, and you're not very sure which files are involved, then only a complete OS reinstall will definitely remove the rootkit, right? And then we have a spyware, very similar to adware, but instead of showing advertisement, it spies on you without your consent. Okay, so we can say it's low threat. It can gather browsing data, but it can be also capturing your personal and financial information. And a very specific kind of spyware that is, I think, very invasive is a spyware that can open up your webcam. That's why a lot of people, they buy a physical blocker to your webcam. So even if they are, accidentally install a spyware, and the spyware operating, because it's physically block the camera, the webcam, then even though they open up the webcam, they can't see anything now, because you physically block the web camera. Okay, so spyware, but not only web camera, audio also. The audio mic they can also take control of. Right, and finally, worm. As I say, worm is self-replicating. They do not need a vector. They do not need another program to infect. They can self-replicate. They can clone themselves, and they can propagate. That means they can spread even without the help of the user. They can spread through network, right? Through network. Okay, and worm, the most famous worm, bring down the entire network. Okay, and it can cause serious disruption to a business. All right, so let's look at common network attacks. All right, so when and malware when it's delivered. So how do we deliver malware? Malware usually delivered via a website. Okay, a website that's already designed in such a way that the moment you visit the website, maybe it will auto redirect, and the auto redirect goes to a file, and the file is automatically downloaded. Okay, automatically downloaded, but it will not be automatically executed. So it still need when it's downloaded, the user still click on it, right? Or it can mask a download with a link, right? When you click on the link, actually you're downloading something, and if you accidentally click on it to execute, then that's it. The malware already execute, and the payload already run on your system, right? So to mitigate attacks, network attacks, you have to understand the types of attack. When we categorize it, then we can address it properly. But what kind of attack is how to mitigate that kind of attack. So networks are susceptible to this type of attack: reconnaissance attacks, access attacks, and denial of service attack. Right? So the video you can get from the NetAttack, you can view this video on the common network attacks I mentioned earlier, right? So we'll skip this showing of the video. You guys have to go and view yourself. Go online and view yourself. Okay, so we look at the first one, reconnaissance attacks. Now, reconnaissance basically information gathering. You want to find out the lay of the land. So even a threat actor, in order to perform a successful attack, they need to know the network environment, what the network topology. The more they know about your networks, the better they can plan or execute the more effective attack, right? So it's short form is recon. Reconnaissance is recon in short form. Okay. So what they want to find out, right? So they will do maybe legitimate. They will execute legitimate commands or use legitimate software or technique, right? To map out your system to find out. Okay, so how many system? What is the topology of your network? How many hosts are there? How many services available on each of the hosts? Are there exist any vulnerabilities on the host, right? So they do this first in order to find out what kind of attack they can perform more effectively in your system. I mean, if you run a network software, there are a lot of network software that can, when you execute, it can perform network topology discovery, and it can tell you how many computers there are, what is the OS of the system, and what are their IP address, all these things, right? So once you get to know that, I mean, for maintenance or monitoring point of view, that is a good information to have, right? But for threat actor, when they know this, then they know which host they can attack and what are the vulnerabilities, right? So that's why it says recon attacks precede. That means happen before access attacks or DOS attacks. They find which of the hosts is the most vulnerable, okay? And then they can try to access it. to attack it. They will try to attack the most vulnerable system first. Right? Some of the techniques used by the threat actors to conduct these recon attacks, perform information query of a target. Right? So first of all, as usual, I want to find out. Before I do anything on you, I find out first. I Google search you. If you're a domain name, I search your domain name information. Check who is and anything that is publicly available about your organization, your system, right? Then I do a ping sweep. Ping sweep, I ping every host available in your system, so I know which host actually available. Because if I ping, it tells me that it's actually that network IP address is correct. And from the IP address, I know network address, so I know your network address. So I know your prefix. I know how many hosts you have in your network. Then to just discover how many IPs are located, I just ping each of the IP address. Any ping reply, then okay. That's why some organization, they actually disable ping from internet. Okay, but there are legitimate use for ping, but some organization, they try to play safe, they actually disable ping reply because of this, right? And then once I know the IP address, I can then do a port scan for individual IP, because port represent what is the service available, okay? The service available on that host. So by doing a port scan, I can, if I, let's say I scan. Usually it's a scan from the low port address all the way to the upper part. Then let's say if I ping, if I scan, ping, try to open port 80, right? And port 80 is available straight away. I know you have a web server running in your host, right? And so forth. Every ping result that port scan that gives me an idea what service is running on your computer. And once I have that, then I check vulnerabilities for that particular port. For example, last time there used to be a vulnerability for SMTP port. Then if you did not patch the vulnerability for that port, I will try to use that vulnerability on that particular port for that particular host. Right? Okay. See, after having the IP addresses, for each IP address, I do a port scan. After I do a port scan, I will run my vulnerability scanners on that port. If that port is secure, then I don't attack it lah. If that port is vulnerable, after running this, then I know already, oh, that IP address has got these ports. These ports are vulnerable to this attacks. Then I run the exploitation tool. You can see from recon, it helps me to find out all the vulnerabilities. That means find out all your topology, your PCs, or all the IP address. Then I do port scan to identify services open. Then I run vulnerability scanners to check whether for that particular service there is a vulnerability available. Then if I discover, then I can run specific exploitation tools to exploit the vulnerability of that particular application, that service, that port for that particular IP address. So this is the step that a threat actor can perform, right? Now all these are technical attack. Yeah, I need to know all this technically. I must be very good to know all these things exist in the first place. But I can use tools. All these vulnerability scanners and explorers are just tools that even if I'm not very good in programming, I know how to use software, right? But there's another type of attack, which is access and social engineering attacks. This social engineering attacks the human person. Remember, human being is also an asset of the organization. and we can also, they are also can be targeted in an attack, right? So what is access attacks? Access attack means you are not authorized to access certain resource, certain service, certain host. Then I want to attack that point of entry so that I can gain access, right? So here, what I can exploit is the authentication services. If there are vulnerabilities in this authentication service, then I can exploit that to gain access, right? So I can find vulnerabilities in authentication services, maybe FTP services, and web services. That means web server. So once I find the vulnerabilities, I can then exploit it to gain entry to web accounts, confidential databases, and other sensitive information, right? So threat actors use access attacks on network devices and computers to retrieve data, gain access, or to access privileges not available to normal user. That means from user, then using this user access, it can then attack other accounts, right? To again access to other accounts with higher privilege. Once I get administrative status in the system, that's it. The system is mine already. I can access everything, right? So that's the ultimate aim for this access attack, to gain administrator status. When you become a root inside Linux server, that's it. You have access to the whole system because you're root, right? So you have to protect this admin account very, very well. Means you have to set very, very strong password. Okay. Right, so password attack attempt to discover critical system password using various methods. Okay, so a lot of cracking tools available. The most simple one will be to use brute force attack. Just simply bombard it with different patterns of password. Okay, usually if you are using randomized password, this very hard to break because the combination of, especially if you use more than 8 characters, it's very difficult to break lah because you have to try one by one. And if you limit password attempt to 3, and then you give a time limit, then it take longer time, right? But sometimes criminals, they know that a lot of password is actually based on common dictionary words, and this is why common dictionary words is not encouraged to use as a password, because they can just simply use a dictionary attack to attack, right? Spoofing attack means you pretend to be something you're not. That means you, for example, the threat actor device attempt to pose as another valid device by pretending, by falsifying data. So spoofing attacks include IP spoofing, MAC address spoofing, DHCP spoofing, right? And we'll talk more about this spoofing attacks later. And other access attack include trust exploitation, port redirections, main interval attacks, and buffer overflow attacks. Okay, I'm not going to go into deep for all this now, right? But buffer overflow attacks, there's a bug inside the software, bugs inside the software. You overflow the buffer, and what happens next allows you to access certain things, right? You're not supposed to access. Okay, in terms of memory, memory. Right. Let's look at the more common attack, because this attack does not need for the threat actor to have very good technical knowledge, because one of the weak point in any system is the human being. So social engineering attack simply means you're doing a con job lah. You're exploiting the human aspect of the security, because humans are the ones that needs to use password, right? Password to basically gain access. So if you can't gain access using technical knowledge, then you will try to attack the human being in the sense that trying um, to get the human person to provide the access password, right? You're actually manipulating them. Okay, so sometimes social engineering means you lie. You lie to that person, to that human being, so to get them to trust you implicitly enough for them to give the information you need, right? So sometimes people just pretend to be some kind of authority coming from maybe your technician, your an engineer related to doing something about maintaining system or something like that. And then you say, oh, you need to access, or maybe your password is compromised. Can you tell me? I check whether your password is compromised. You pretend to be from person of authority that people implicitly trust, especially non-technical people inside your organization. Okay, and they are bombarded with all the technical terms and authoritative sounding person on the other line, and they tend to tend to trust lah, especially if they reveal. That's why the recon part, they find out more about the organization. So when they talk to doing the social engineering attack, they talk to those non-technical employee, they sound so convincing because all the words they use are all correct, right? They know about the IT department. They know, okay, I'm replacing who and so and so. So and so happens to be the person from IT that this person know. Oh, okay, you know, okay, then they implicitly they can't imagine that someone else will know very detailed thing about their IT operation to suspect something is amiss, right? So they will do this. They will do they recon first. They find out everything they can about the information about the organization. So when they do these social engineering attacks, they sound so convincing, right? They sound very convincing. It's as if they know things inside the organization that only employees know. So of course they will trust you lah. They will trust already. So when they trust, the moment they trust you, then it's easy to get them to give you um, confidential information. So how to stop this kind of attack? Unfortunately, it's just training. Or fortunately, it's just training, right? You train your employees, okay? Not to trust lah. Maybe there is a proper procedure to gain access to system. If we cannot just simply from the phone, or there must be a form to fill out. All these procedural must be placed in to prevent social engineering attacks, right? So social engineering attacks, okay? Pretexting, right? So a threat actor pretends to need personal or financial data to confirm the identity of the recipient. Well, because this is what officially a lot of financial institution or authorized organization also do this. Okay, they want because they are seems like authority. They want to confirm identity of the recipient. Then they ask you for personal details. Okay, so unknowingly, you already give some of your personal data that can be used for further attack later. Okay, phishing. A threat actor can send a fraudulent email. The email looks exactly like official email, right? It's look like the legitimate, trusted email, right? Then they trick you into installing malware on their device. It could be they were saying that they are from, let's say you already find out that the organization is using Google Drive, Google App, Google what. Then they pretend that this email is disguised as coming from Google. And they say, oh, all right, we detect that in order to upgrade your Meet can you install this Meet software? It helps you to. Then they click on the Meet, supposedly lah, pretend lah, just an example. So the user who is not very technical wants the her Meet to be more efficient, always, always crashing. Now it runs better. It says, oh, new. So if you install this later, your Meet will work extra fast. Some just example lah. So they will be tricked into clicking on it to execute it, and then your malware is already running in the system, right? Spear phishing. A threat actor creates a targeted phishing attack tailored for that specific individual. Again, this based on the recon. They will check, okay, they will find out who is in charge of what. They'll check, do they have social media? They will find out every little details, okay, about this specific person. They might even do such thing, not only social media. They go to the company to find out in detail about this person or this whatever lah, right, information, so that they can be very convincing when they're doing their social engineering attacks, right? So, for example, very deep personal. So, is your name so and so? Is your mother's maiden name so and so? Do you live in this? Oh, okay. So we are from actually from IT. HR already confirmed to us. It's so convincing because they know details that public don't know, right? But because they already did those one, spear phishing. Spear phishing is targeted, right? It comes from the English word spear phishing, where you use a spear to catch that particular fish. You spear fish it, so it's very targeted attack, right? All right. So and then some is spam, is junk email, and it's unsolicited email. Sometimes this junk email comes in very attractive. Click. What happens? What is the latest on BTS? You won't believe their whatever their video on whatever, very good. So they did already lah. They know, they go to social media, they find out, oh, you like BTS. You click lah, right? You click because, oh, although it's unsolicited, but it's very attractive because, oh, they there's some gossip about my favorite, or you click lah. You click and then that's it. Again, the malware already run. And to make it more convincing, they actually load the BTS video afterwards. So, you're looking again, and then you don't realize by clicking, the software runs. Yes, you saw a BTS video, but the software also already run. Okay, something for something, right? So something for something is quid pro quo, means a lot of people, when you give them something free, okay, they're willing to they're more willing lah, right, to do. So that means you can say exchange for such a gift. Maybe Lazada, Lazada credit, or Lazada, something like points lah, something points, so something that they attractive to them, right? So maybe fill up the form, you get a chance to win a new Mac Pro computer, or a new iPhone computer. Okay, do you recall how many times you get send this kind of link by as forwarded to your WhatsApp? You ever get forwarded or not? Kelvin, Noel, and Aftera get forwarded with, fill up this form and get 3 GB for your whatever DG car or what. Someone sent to you? Ever before?
Yes.
Yeah,
Yeah, got.
ada kan? Right? So this is because this is attractive. This gift is attractive. So sometimes social engineering attack is something for something. They know it's very attractive to you, so then they will use that. All right. So you basically greed, I would say lah. So sorry, it sounds so bad. Greed bypass your caution because give free iPhone or free whatever. Yeah. So you click lah, you click the link, you fill up the form. When you fill up the form, they get your information. Again, that is your personal. Then you forget about it, and sometime later they will use it. They will use the personal information as a further social engineering attack. Right? Baiting. A threat actor leaves a malware infected flash drive. Now this is really again greed over caution. You suddenly saw a pen drive. 128. How come? Oh, I think it's too high. It's very suspicious. So maybe it's 64 gig or even 32 gig pen drive, right? So be honest. If you see a pen drive, you're very, very attractive to pick it up, especially it's in a public area, it's dropped down there. Even if not for using, you're wondering, oh, what's inside it, right? What's inside it? But it has the boot sector of the flash drive, or it's already set, unless you set not to auto run. But the moment you plug in the flash drive, it runs something, then malware is inside already. Right? It's all, some people still set their pen drive auto load. Maybe even if technically you are knowledgeable, but you know it's just convenient auto load something, right? So plug in the malware auto loads, auto run. Guess I so lucky I got the 64 Corsair pen drive, flash drive, or whatever lah, kan? Right? That's baiting. It's a bait. Umpan lah, is a bait. Impersonation is when they pretend to be someone who they're not in order to gain your trust. Again, I give you an example. They say they're from IT, they are checking up your computer, or they say they're from Google, they're checking up whatever. Okay, so they pretend to be someone that's trustworthy for you to trust them. Tailgating, right, is physical access. They follow you. Okay, if you're not aware, they follow you, they tailgate you. You can get into secure location, but when you open, you don't straight away close. They slip behind you. They have access already. Okay, this tailgating. A lot of times in movies we see these people do tailgating, right? They follow you, pretend just following. Then you pass by a server room, you open, you go in. They just put their feet down a bit. You went in or you not notice already. And of course, it's only work if you're entering building or a location that there's people or whatever, that it's easy for them to not to be noticeable lah. But this is one way to gain access to a place where they're not supposed to gain access, by tailgating the authorized person and slipping in when the person is not careful. Okay, shoulder surfing is okay, and we're always aware of this. Okay, when you go to ATM machine, you try to block, right? When you type in your password, your PIN number, you try to block with your body or whatever, right? So that other people cannot shoulder surf and guess your password. It's basically they just lean over like that, unknown to you, in your blind spot, and then they can see what you're typing, right? When they see you're typing, they already steal your password or your ATM pin, because you didn't notice they are just leaning like this a slight bit, little bit, and then saw which number you type in. Then they know your what already, your the name, they know what your password is already. Dumpster diving, okay? So dumpster diving is basically because a lot of trash we throw, okay? So not all companies shred first, especially confidential information, and sometimes not so confidential information, but it's still useful for social engineering. Is get thrown in the trash. right? Especially in big companies, you get thrown in the trash. They don't even bother to shred. And if they shred, it's not really those very good shredder. So dumpster diving basically means you go into the trash. US slang call it dumpster. It's actually a trash. And then they go in and dive in means because it's a big dumpster, right? They go in and search for whatever information they can from there. Okay, so the way to defeat this is actually for very or for a lot of the information, you should shred first and use a good shredder, maybe crosscut shredder to shred. Okay, so that people cannot. In fact, I think Bill Gates ever do this, but not for hacking. Bill Gates go into company when he was still in college or in high school. He went to dumpster pick up, but those are program codes. Program codes he wanted to learn, he wanted to know, so he gained access to dumpster. A lot of those codes was printed out, and now they no longer need, they throw away. He go and read them. Bill Gates ever do that? Dumpster diving. Okay, right. So we have this something called SET, Social Engineering Toolkit, that is designed to help white hat hackers and other networks, InfoSec, like network security professional, to create social engineering attack to test their own network. So penetration testing doesn't only involve technical attack. It also involves social engineering attack. So this toolkit is used by them to do just that. So how to mitigate against this? Organization must educate their users about the risk of social engineering and to develop strategies to really able to validate identities over the phone, via email, or in person. In fact, a lot of times, banks will tell you, in order to prevent this kind of attack on their user, banks will tell you, we will never ask you personal details over the telephone, right? So if you find that the bank is asking for personal details, remember that banks nowadays do not want to ask personal details over the phone. They will not, surely not asking you about your account number or whatever, right? So you be wary. If they ask you, then you say, okay, I'll drop in the what branch, okay, physically. Then I'll tell you there. When do you want me to be there, like that? Okay. Right, so this figure here shows recommended practice that should be followed by all users. Always report suspicious individual. These are the procedures that can be done by organization to prevent social engineering attack. Always log or sign out of your computer when unattended. Never reuse work-related password. Never release work-related info on social media, because this is the first place they do recon. Never open emails from untrusted sources. Never leave your username, password, credential where they can easily be found. That means you write on a post-it note and just write somewhere. Never give your username, password, credential to anyone else. Always destroy confidential information according to organization policy. It means use Shredder. Okay, all right. So these are actually the basic rules. There might be more detailed procedures to protect against social engineering attack. All right, so I'm gonna stop here because we've reached 4 o'clock already, right? In fact, we only reached 36 out of the 80 slides. So we're going to continue this before we move on to ACL actually, okay? Well, if need be, we will do additional class just to cater for this. A lot of topics here, but in this, we need to cover also anyway. Anyways, for tomorrow, practical, we'll find a suitable replacement time. So I think Noel maybe can suggest later on lah, huh? Suggest when is the time. I know that other lecturers also finding time slot with you guys because affected by the Chinese New Year, right? but we'll find suitable time. Maybe Noel can schedule or suggest a time. It can be Saturday, and replacement or additional class replacement for Chinese New Year, the replacement, right? We can do it online also, right? Even though it's after 15th of February, because remember 15th of February we go back to campus already face to face. But if we have replacement class and we can hold it convenient time, okay, maybe during Saturday, okay, it can be online. All right. Okay, so I will upload our tutorial later. Noel, I know I haven't create the website for the Google Classroom for you yet. I will do it. I'll invite you. Farah and Kelvin, I know that Surayani is on leave, so I will arrange, for both of you, just to at least do at least one or two consultation before Surayani comes back, in terms of final year project lah, right? I also create not only for Noel but for Kelvin also, just to share some template information. All right. So any question on anything and from this topic, or what I said mentioned earlier on?
No, these all learned before in other past courses. So we talked
Okay,
about
okay. Right. So maybe I can move very fast in here, but I think we're going into some parts that is not. For example, this part is maybe not covered before. Anyway, any question? Any other question? Farah, Noel, Kelvin.
Sir,
No.
is it okay to not to replace the practical tomorrow? Because maybe sir only upload the packet tracer only. Can we just submit only? We need to attend.
Is if Kelvin and Farah is agreeable, then that's okay.
I think I agree on that as well.
How
Yes.
about you, Kelvin?
Just to upload.
Okay.
The practical, or need to replace? If need to, if you have any question about
okay.
it, yeah. If you have any question about it during other practical, can still ask the question, of course.
Yeah.
All right, so I'm okay with it. All right, if
Okay.
you guys are okay with it. Okay.
Okay.
All right. So thank you very much for today. I want to wish all of you happy Chinese New Year's Eve tonight. Be safe, be with family, be happy. Um, also, happy holidays for this couple of days. All right.
Okay.
Stay safe,
Okay.
yeah.
Yes, sir.
If you,
sir.
yeah, if you visit places, also please observe SOP. I want you guys to be healthy, but celebrate
Okay.
celebrate with families. Okay. All right.
Okay. Thank you, sir.
Okay.
Okay, sir.
Thank you,
Thank you.
everyone.